Okay, these are some more equations. Call this number 6, A, B, and C. And they get a little bit longer, but not too bad. Now again, 8 sine of x plus the square root of 2 equals 6 sine of x is an equation. And we want to solve this for x, so basically, first of all, we want to find out what the sine of x equals. So we'll try to isolate the sine of x. So just think of it as like a special variable like z, and we try to get them all the same side. So first of all, I try to get all my sine of x on the left. So I can subtract 6 sine of x from both sides. And that's just going to be 0. And this is going to be 8 minus 6 is 2 sine x plus the square root of 2 equals 0. Then I can subtract the square root of 2 from both sides. So I get 2 sine of x equals negative the square root of 2. Then divide both sides by 2. And I'll get the sine of x equals negative the square root of 2 divided by 2. So we know that this is going to be pi over 4, but again, what quadrants are these in? Well, remember when the sign is negative, I'm going to be in these two quadrants. I'm positive in quadrant 1 and 2, and negative in quadrant 3 and 4. So I'm going to be negative, and this is going to be, again, the sign of x equals the square root of 2 when it's pi over 4. But since I'm in these quadrants over here, this is going to be 1, 3, 5 pi over 4, and 7 pi over 4. So that implies that x equals 5 pi over 4 and 7 pi over 4. And of course I'm in these two quadrants. Okay. Over here, let's take a look at this one. It's a little bit easier. Just subtract the square root of 3 from both sides, again to isolate the cosine x. So I get 2 cosine of x equals negative the square root of 3. And then I divide both sides by 2. So I get the cosine of x equals negative the square root of 3 over 2. Now again, I know that the x, when let's say the cosine of x equals the square root of 3 over 2 when x equals pi over 6. All right, but I'm going to be negative. So where's the cosine negative? That's going to be in quadrants 2 and 3. Remember, the cosine is positive in 1 and 4, so it's negative in 2 and 3, so I'm quadrants 2 and 3. This will be pi over 6, so this is going to be 5 pi over 6 and 7 pi over 6. So that will imply that x equals 5 pi over 6 and 7 pi over 6. My 5 pi over 6 here and my 7 pi over 6 there in quadrants 2 and 3. Now this one is a little bit easier than it looks. Don't let the sine squared bother you. So again, we'll try to isolate the sine squared. So we've got 2 sine squared of x equals 1. I divide both sides by 2, so I get the sine squared of x equals 1/2. I'll take the square root of both sides. Remember, when you take the square root, it's got to be plus or minus. So the sine of x equals plus or minus the square root of 1/2. And that's the same thing as plus or minus the square root of 1 over the square root of 2, which is the same thing as plus or minus 1 over the square root of 2. Now this doesn't look like any of the values that we're familiar with, but if we rationalize the denominator, square root of 2, square root of 2, we get the sine of x equals plus or minus, and this is going to be the square root of 2 over 2, and we know what that is. That's pi over 4. Now since it's plus or minus, it's going to be plus for 2 quadrants and negative for the other 2. I don't have to worry, it's going to be all 4 quadrants. So x in this case will equal pi over 4, first quadrant, 3 pi over 4, second quadrant, 5 pi over 4, I'm sorry, 2, why am I saying 4? Pi over 2, 3 pi over 2, I'm sorry, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So I'm getting a little tired here. Okay, so again, we know that the sine of x is plus or minus the square root of 2, implies that x is equal to pi over 4 square root of 2 over 2. But we're in the positive and negative, so that takes care of 2 positive quadrants, 2 negative quadrants. So again, that's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, hope that helps.